Let's talk about something you probably interact with hundreds of times a day. Your documents, your photos, your music, they're really the basic building blocks of our entire digital world. But have you ever actually stopped and wondered, what is a computer file? Well, in this explainer, we're going to pull back the curtain on this piece of tech we take for granted. Right? I mean, you see an icon for a vacation photo or a spreadsheet, but what does the computer see? When you double-click on that thing, what is actually happening under the hood? That's exactly what we're here to figure out. You might think the whole idea of a file is pretty modern, but the concept is surprisingly old. We gotta go all the way back to the 1940s and 50s. Back then, computer scientists just borrowed the idea directly from the paper files in their offices. In fact, this ad from 1950 talks about keeping data on file in a memory tube. So the core idea of storing and retrieving stuff has been with us from the very beginning. So, what's the official definition? It's actually really simple. A computer file is just a named collection of data. That's it. To your operating system, it's one single thing, and it doesn't care if that thing is a tiny one-page memo or a massive 2-hour movie. Okay, so a file is a thing, but your computer has thousands, maybe millions of these things. How does it keep track of it all without just descending into complete and utter chaos? Well, that's where the file system comes into play. The absolute easiest way to think about a file system is to picture a giant physical filing cabinet. It's a structure, right? It's designed to store and organize everything in a really logical way so that you, and more importantly the computer, can find anything in an instant. And this is exactly how that organization works. Every single file needs a unique address, which we call its path. Think of it like a set of directions. As you can see here, you start at the root, that's the whole cabinet. From there, you go to the payroll folder, that's a drawer. Inside that, you find the salaries subfolder, your manila folder, and finally, you arrive at the document itself, managers.doc. So, this brings up a really crucial point, the difference between a file name and a path. The file name is just the name of the paper, managers.doc. But the path is the full set of directions to find that exact piece of paper starting from the very beginning. And no two files can ever have the exact same path. All right, so we know how to find a file, but what are we actually finding? What is a file really made of? Let's peel back the cover and take a look at the raw data inside. Now, this might sound a little technical, but it's a wild concept. No matter what you see on your screen, a photo, a song, a video game, at the most basic, fundamental level, it's all the same thing to the computer. Just a long, single-file line of bytes. And a byte is just a little packet of information, a series of ones and zeros. But wait a minute, if everything is just a string of bytes, how on earth does your computer know the difference between a picture and a song? Well, that's where that little tag at the end of the file name comes in, the extension. Think of .jpg or .mp3 like a label on a box. It doesn't change what's inside, but it tells the operating system what tool it needs to use to open it. It's the decoder ring that turns a bunch of gibberish data into the content you actually want to see or hear. So, we know what files are. We know what they're made of. Now let's talk about what we actually do with them. This brings us to the most basic actions or operations that our programs are performing on files every single second. These are like the fundamental verbs of the digital world. When you save a document, your word processor is writing to a file. When you open a photo, your computer is reading from a file. Literally every single thing you do on a computer involves some combination of these basic commands, all happening constantly in the background. Now here's a fun one. You've probably experienced this without realizing why it happens. When you move a big folder, say from a USB drive, some systems move one file at a time, deleting as they go. But others copy everything to the new location first and only delete the originals at the very end. That's why if a huge transfer gets interrupted halfway through, you sometimes look back and see that no space has been cleared on the original drive at all. With all this data constantly being created, changed, and moved around, how do our computers protect it all from accidental or even intentional harm? Let's take a look at the built-in safety nets. So operating systems have a few layers of protection. Permissions are like the bouncer, controlling who can do what. A read-only flag is basically a do not touch sign that prevents accidental changes. And that hidden flag? That's used to tuck away really critical system files so we don't accidentally delete something important and break the whole computer. But what happens when that protection isn't enough? Let me tell you a quick story. Right here, we have a perfectly healthy JPEG image file. Every single 1 and 0 inside it is exactly where it's supposed to be. It's perfect. And this is the exact same file after one tiny, tiny error. A single bit, just one solitary digit out of millions, got flipped from a 0 to a 1. The result? Total chaos. We call this file corruption. The instructions are now complete gibberish, and the program trying to read it just gives up. So how does this catastrophic failure happen? It's usually not some big dramatic event. It's something super mundane, like the power flickers out while you're saving, or you get a virus, or even just yanking out a USB drive without clicking Safely Remove first. So what's the best defense against the risk of your files turning into digital mush? Well, it's not glamorous, but it is incredibly effective. Backups. Just making copies of your important files and keeping them in a separate location is the single most powerful way to protect yourself from losing everything. When you really think about it, the humble computer file is the foundational building block. It's the digital atom of our modern world. And as we create trillions more of them, the real challenge isn't just about where to store them. It's about how we're going to manage, protect, and find meaning in this endless, growing sea of information. I hope this gave you a new appreciation for what's happening every time you double-click. Thanks for joining me.